Kennedy Space Center, morning of January 28th. It was the most anticipated mission after 6 postponements due to unstable weather conditions and technical problems. The launch of the Space Shuttle Challenger for mission STS-51L was finally confirmed for January 28th. Challenger was the third space shuttle built by NASA and completed in July 1982, and it was part of a fleet of 5 space shuttles: Columbia, Challenger, Discovery, Atlantis, and Endeavour. The first space shuttle that was built was Enterprise, and it was used only for carrying out various flight tests, including testing the vehicle's aerodynamics, controllability, maneuverability, among several other parameters. These tests were carried out at high altitudes with the help of a Boeing 747, which carried the space shuttle supported by a specially built device. Then, the space shuttle would separate from the Boeing 747 and the tests were carried out at altitude. The Challenger had already completed 9 successful missions over 3 years of operation, having sent more than 50 astronauts and traveled more than 41 million kilometers during its operation. 7 crew members would be part of this mission: the physicist Ronald McNair, the pilot Michael Smith, the engineers George Jarvis, Ellison Onizuka, and Judith Resnick, the mission commander Francis Coble, and the teacher Krista McAuliffe. Krista would be the first civilian teacher to fly in space. She would give 2 15-minute lessons from space to 2.5 million students as part of the Teacher in Space project. On the afternoon of January 27, 1986, that is, the day before the launch, the weather forecast was for exceptionally cold conditions for Florida at the Kennedy Space Center with very low temperatures, specifically -2 degrees Celsius, in the early hours of January 28, the scheduled launch day. During the early morning of the launch day, the cold weather had covered the launch pad with ice sheets of 7.5 centimeters and icicles over 1 meter long. It would be the first launch in such cold conditions. The engineers expressed concern that in such cold temperatures, the O-rings could harden and fail to seal the joints, allowing very hot ignition gases to escape. And among those engineers was Roger Boisjoli. Boisjoli was against the launch because he knew that the low temperatures would put the mission's safety at risk. Boisjoli tried to stop the Challenger launch, advising NASA and Theo Cole directors to cancel the launch. But the directors considered his claims inconclusive and went ahead with the launch. The space shuttle is made up of 3 main parts: the orbiter, which contains the crew compartment where the astronauts are, the cargo bay, where satellites and other cargo are placed, and the rear section, where the 3 main engines of the spacecraft are located. These engines could burn approximately 4,000 liters of fuel per second, generating 1,859 kN of thrust. These engines were fueled by the propellant from the main tank, the orange one, where about 2 million liters of propellant were stored, that is, 1,476,000 liters of liquid oxygen and 548,000 liters of liquid hydrogen, kept at temperatures of -182 degrees Celsius for the liquid oxygen and -252 degrees Celsius for the liquid hydrogen. Despite all that propulsion, it still couldn't lift the vehicle off the ground. So, 2 solid fuel rockets were needed, containing 499 tons of solid fuel. Together, they would accelerate the vehicle to over 28,000 km/h, the speed needed to overcome Earth's gravity and keep the vehicle in orbit. At 11:38 in the morning, the final countdown for the launch begins.
7, 6.
The engines are started and the space shuttle leaves the launch pad.
Liftoff of the 25th Space Shuttle mission, and it has cleared the tower.
Immediately, the Space Shuttle's computers execute the roll maneuver, positioning it on the correct trajectory for orbit. At 73 seconds into the flight, the Space Shuttle explodes in a gigantic fireball. But what went wrong? After the accident, a presidential commission was formed to investigate the causes, and physicist Richard Feynman was part of this team. Raises risk of joint failure, similar to a committee.
It was like a committee decision. There wasn't a single person responsible.
Yes.
The commission then decided to watch the launch film again, which was recorded by more than 60 cameras around the launch platform. 6.6 seconds before launch, Challenger's main engines are ignited, reaching full power. At that moment, anchor bolts still secure the vehicle to the ground. Due to the enormous thrust, the vehicle makes a slight movement of 1 meter forward and returns to the vertical, a phenomenon known as twang. Right after that, the solid fuel booster rockets are ignited and the bolts are released. Next, the vehicle takes off. At 2 seconds into the flight, a camera captures a mysterious, thick black smoke appearing behind the right booster rocket, near the left tank. A few seconds later, the mysterious black smoke disappears. The shuttle continues, and at 37 seconds, Challenger enters a strong wind zone lasting until 64 seconds. These winds create extreme aerodynamic forces, which are detected by the flight computers, prompting them to make corrections to return the vehicle to the correct position. At 58.7 seconds into the flight, a camera captures the appearance of a flame on the right solid rocket booster, the same booster where the mysterious black smoke had appeared earlier. The flame continues to grow in size, directing the fire toward the orange external tank, where all the vehicle's fuel is stored. From 64 seconds to 72 seconds, the flame penetrates the external tank, and the liquid hydrogen begins to leak. At 73 seconds, with the vehicle traveling at 2,352 kilometers per hour, the right booster detaches from the structure holding it, collides with the upper part of the external tank, and the vehicle explodes. After the explosion, the 2 solid rocket boosters keep flying and are destroyed by remote control from the Flight Control Center. That black, swirling smoke cloud was remarkable. During the investigations, it was discovered that during the ignition of the solid rocket boosters, the right booster had a malfunction. The rocket is made of 4 segments joined together by bolts, and the point where they are joined is sealed by a pair of special rubber rings. The rockets are ignited by directing a flame downward into the center of the solid fuel. The sealing rings must flex to prevent the high-pressure gases from escaping through the rings. But due to the low temperatures on the day of the launch, the rings, which are made of a special rubber that performs well at high temperatures, become hard and brittle when subjected to low temperatures, making them susceptible to failure. And when the rockets were ignited, these rings did not seal properly, allowing high-temperature gases to leak out, destroying the vehicle at 73 seconds into the flight. These events led to the tragic Challenger space shuttle accident.